All right, this video will cover how we collect data for the friction experiment. I'm Tom, physics lab tech,
I'm Connor, I'm another physics lab tech.
and we're going to be starting off with the friction blocks here. We will be examining first the surface area versus force to keep these being dragged across at a constant speed. We'll always use the two friction blocks. We'll pull them both with the maximum area, then we'll pull them stacked on one another, then we'll stack them on using the narrow edge. The friction blocks have felt on two sides and wood on two sides. We will just be examining the felt side for this particular experiment so as not to put in more data than you need. So let's get the blocks in position. Get ready with a force probe. A force probe, if you did not see the video on the force probe, it is simply something that records at 250 times per second the amount of force that is actually on the hook. So, and we need our string set up to pull on it with. So let's see, so if we put the string here now, Connor, what's going to happen if the string is not exactly parallel to the tabletop?
We'll be introducing a normal force and then we'll have to do trigonometry.
Do you want to do trigonometry?
Let's avoid it if we can.
Okay, well, some of the students might like to do trigonometry, but we'll have to disappoint them. So we will go ahead and commence data collection. We'll put the force probe in position. We'll hit the 0 on the force probe. And I'll give it a pull and a stop. A pull and a stop. Slack the string on the stop so that marks a 0. A pull and a stop. A pull and a stop. And that should give us enough data. So
And you can see I added a 500-gram weight on top to keep the blocks together and weighted down.
Gives a little bit better data, so we stop data collection. And we'll take a quick look at what we got. We can zoom in on the screen here. First thing, we'll clear the green fog because it's by setting a limited analysis box, which we won't really be using the analysis box. So for the first 10 seconds, we're just simply getting the string lined up and the force probe zeroed. Then as I pulled, it gradually, you saw that the static friction broke free at this amount of force. Then it pulled with a relatively constant force. It's got wiggles in it, but this is the real world, not exact theoretical. Then I just stopped, and the force is actually 0 when I stopped, which just says that the force is probe 0 is correct. And I just repeated that 3 more times for a total of 4 data points. And you can see that these are not all exactly the same, which is, again, maybe the tabletop is slightly different in some places, or sometimes friction just depends a little bit on things. It's basically just a mathematical model anyway. So now as far as when you analyze this, if you're analyzing it in Excel, what you're going to need to do is note where the peaks are and approximately in the time. So this first peak right here is just about at 13 seconds. And the time is in the middle column here. And like we said, 250 cycles per second times 36 seconds. What's that multiply out to, Connor? A lot, right? So,
1,000?
yeah, some thousand. So, well, that's hard enough to count. So anyway, you have a lot of data points to scroll through if you're just going through blindly. So focus on the middle column here, the one that marked time. And we're going to go back to, what did I say, 13 seconds. So around 13 seconds, and the value is about 2.9. You can actually read that off the graph. So somewhere in this data stretch here is your maximum. The others, you'll simply take an average from about 13.5 seconds to about 14.5 seconds. You'll do this on an Excel spreadsheet and get the average and standard deviations. Then you'll simply do this with the other two peaks and use that to get your data. We've reconfigured the block so that we have only one broad surface set up. We will line up the device. We will commence data recording. Put a little stress on it. We'll drag, stop, drag and stop, drag and stop, drag and stop. And that should be adequate. So we'll stop the data acquisition. And you see we have the same kind of thing, and now shows up in red. This particular one, the first one, is sort of a dud because we did not get the static friction point. We did on the others. And and 3 will be good enough. So you'll analyze this in the same way we just said on the first set. So that said, we will proceed to drag with using only one narrow edge. Now this calls for repositioning the pulley to keep the string level, as we previously said. So we'll measure here, reach 28 millimeters. It's 30 right now, bring it down a little bit. It's 28 now, so we have it set at the correct height. So we will see if we can balance all these things and slide them at once without the thing crashing down. Set up and record. Slack, drag, slack, drag, slack, drag, slack, drag. All right, so what have we got here? We'll stop recording first. And observing just the blue, we again have the same kind of pattern for you. So putting them all one on top of the other, you can see that the force to keep this thing moving at a constant speed is all reasonably consistent across those three things, and you can analyze it more closely. Well, just a reminder in that last section with the varying the surface area, in each case we had the normal force was the combined weight of the two blocks plus 500 grams, so don't forget to include that 500 grams if you go to calculate the coefficient of friction. So the next phase of the experiment is going to be to measure the coefficient of friction for several different surfaces. We have 3 identical looking friction bins here. We have a place you can attach a string to drag them by, and a bin that you can put some weights in to vary the normal force. But they're not identical. One of them has a polyethylene bottom, another has a felt bottom, and the third one has a cork bottom. So we will be doing each of those in a similar manner to what we did before. We will do 3 different data files, one for the felt. They'll start off dragging the empty felt, and you have this mass, this thing is shown somewhere in your data. Then we'll add 500 grams. This is 200 plus 50 at one end and 200 plus 50 on the other, so that the weight is balanced. Drag it again. And last we will do with 1 kilogram added to it, or 1,000 grams, 500 in one end, 500 in the other, again to keep it balanced. And we will do the same 4 trials on each of those. 4 trials means if one of them doesn't show good data, you can simply reject it. And from that you will be able to determine the coefficients of static and kinetic friction of these 3 different surfaces. All right, we're set up to measure the felt bottom bin with empty, so the normal force is simply its weight. You have its mass, and you can convert that to weight. So we'll set up the pulley. Ooh, we better set it up the proper. Connor, put 500 grams in the friction bin there just to hold it in place. So it'll stand on the weight here. And the weight of the probe will hold it in place. We'll get our magic ruler.
It's like 38 millimeters.
Okay, give me that stick because I need the same stick. And we'll set this to 38 millimeters. It's 38 millimeters. And now we are ready to take data. So as usual, we will start the data collection.
Is this for the empty?
This is for the empty, so yeah, pull out the 500 grams.
Okay.
We'll select the string, start data recording, 0 the probe, and start pulling. Stop, select the string, start pulling, stop, select the string, pull, stop, select the string, pull, stop, select the string, pull, select the string. All right, we will stop the data acquisition. And we will scale the graph so you can see it a little bit better. So, some kind of dud action right here. We have some good data here. 1, 2, 3, 4, 5. They're all good. They don't exactly agree, but that's just the nature of physics. So, Connor, what are we going to do now?
I think we should add a little bit of mass into this bin.
Okay, let's do 500 grams, but let's not do it with a 500 gram. Let's put 250 at the front end and the back end.
Okay, distribute the weight a little bit evenly.
Well, we just don't want to deal with the idea that, if it's cockeyed, it's going to upset the results. We'll set up once more. We will start data collection. We will pull, stop, pull, stop, pull, stop, pull, stop, pull, stop, pull, stop. And that again gives us enough data. So we will stop the data collection. And we will continue with 1,000 grams added to the felt. And then we will continue in exactly the same manner with each of the other 2 friction bins, and you will have those data files to analyze. Remember, you've got to kind of look at the overall graph in Excel. If you're analyzing with Excel, you have to look at the overall graph and then zero in on where you're going to look, or you have to learn to use a maximum function in Excel, and you'll want to learn to use the average and standard deviation functions in Excel to take a series of the data. Okay, well, good luck on this experiment.